Good morning, good morning. Hope all is well. Hope everyone's doing all right. We'll get started in a few minutes as soon as everybody gets in. Good morning, good morning. All right, looks like everybody is in. Good morning once again. Hope you guys had a great weekend. Everybody's ready to get rolling. So last class, some people sent you definitions already, so appreciate that. But last class, we said 7.1 was going to be a list of definitions. So they're in your math lab. Same place where you saw chapter 1 and 2 definitions. And then we went through 7.2. So we're looking at 7.3 today. Maybe we'll get to 7.4, maybe not, but we'll most definitely knock out 7.3. And 7.3 is the central limit theorem for sample proportions. All right, so central limit theorem. It tells us that if some basic conditions are met, then the sampling distribution of the sample proportion is close to the normal distribution. And so always when we mention normal distribution, we're talking about our bell-shaped curve. And if we can lean on a normal distribution, then that means we can use our z-scores. So that's what that means, basically. Use our z-scores, a z-score chart. All right, scrolling up some. So we'll go through the conditions. First one, we have random and independent. So if your samples are collected at random, and are independent of each other, it's one of the conditions. Then we need to have a large enough sample size. So your sample has to be large enough to have at least 10 successes and 10 failures. Write down 1. Someone said something. Oh, hold up. Yep, not a problem. All right. Third condition, you want to have a big population. If the sample is collected without replacements, then the population must be much bigger, so at least 10 times bigger than the sample size. Number 2, can I scroll up? All right. Central limit theorem tells us that if our conditions are met, then the sample distribution of p hat is approximately. And we have p, well, in parentheses, it's just a notation of symbolism. And I'll scroll all the way up before I describe it. Just want to give people a chance to finish copying the purple. Not purple. Everybody still copying purple? All right. So notice how they give us the notation. In red is the normal way of notating it. Is N, which represents the capital N, parentheses. Let me see, a number, comma, another number. So whenever you have that capital N represents your normal distribution. And in that normal distribution, your mean, which is the first one, is your first number, and then the standard deviation is the second number. Whenever you have that notation. See, do I have an example? Okay. So it's telling you that P would be your mean, then the square root of P times 1 minus P over N would be your standard deviation. But also don't forget that that is also your standard error. We talked about that last section. So once again, once the conditions are met, this means that your P, remember, is our population proportion or population percentage. A lot of times they give it to us in percentage. So P is going to be our mean, and then the standard error would actually be our standard deviation. All right, scrolling up some. So and then in red, you say, C says, if you don't know the value of P, then you can substitute the value of P hat, which is our sample proportion, to calculate the estimated standard error. All right, can I scroll up? Better done with the green. All right, so give you a chance to write stuff down, but we're going back to pet world. Remember last class we talked about pet world. That was our example, and we had our cat people, people who love cats, hate dogs, and all the good stuff like that. So population is 1,000 people, and the proportion of cat people is 25%. So we'll take a random sample of 100 people. All right. Let me erase some of this stuff. So what is the approximate probability that a proportion in our sample will be bigger than 29%? Of course, if I scroll up too far, somebody's still copying, let me know. All right, so once again, what is the approximate probability that the proportion in our sample will be bigger than 29%? So first, we want to begin by checking the conditions for the central limit theorem. Have to meet our conditions. So number one, is it random independent? The answer is yes. So it says we'll take a random sample of 100 people. So we're just talking about randomly picking out people, and random, just picking out people, and then independent means the probability if you pick somebody does not affect the probability of you picking someone else. So it's random and independent. Then number two, it says at least 10 successes and at least 10 failures. So in order to figure out the successes, we're talking about taking the proportion probability, which is 25%. You go back to the problem, 25% cat people. So that's your proportion, your population proportion. So you multiply that times 100, which is our sample size. As long as it's larger than 10, or at least 10. And then we do the same thing for failures. So now if there's 25% cat people, you minus that from 1 or 100, then that means you'll have 75% non-cat people. And so you multiply that times 100. So both of these numbers have to be at least 10 when you multiply that times your sample size. Whatever your population proportion is, you multiply that, and then its complement towards your sample size. And both of those numbers need to be at least 10 in order for it to meet the conditions of your central limit theorem. All right. Questions on that before we go to 3? And then you need a big enough population, at least 10 times the sample. So your population, which is capital N, is 1,000. And our sample, lowercase n, was 100. So 10 times 100 is 1,000. So there you go right here. So that's good to go. So before we go any further, make sure we're okay with the fact that we met each one of the criteria for our central limit theorem. All right. So next you want to calculate your standard error. That's the square root of p times 1 minus p over n, lowercase n, which is our sample. And of course, you could just throw it in your calculator right here, but I just did steps just for board purposes. Making sure everybody's okay. So once you're done calculating, you should get 0.0433. All right, so that's our standard error. Right down with the purple. Okay, then we want to convert to a z-score. So now, if you go back to the problem, I'm gonna scroll back down, but go back to the problem. We're talking about bigger than 29%. So remember when we did our z-scores, you have something less than a certain number, bigger than, larger than a certain number, something like that. So the comparison number is 29%, and we want to know about being bigger than 29%. Our sample being bigger than 29% cat people. So this would be the way that we would calculate our z-score. Remember we talked about your population being your mean, standard error being your standard deviation. So notice they're fitting right in the formula as our mean and standard deviation. And p hat is going to be our x value, data value that we're doing our comparison to. So that's p hat minus p divided by SE, 0.29 minus 0.25 divided by 0.0433 ends up giving us 0.92. So don't forget, we want to round all of our z-scores to 2 decimal places. All right, everybody good? So go to the chart. So let's make sure we Haven't forgot how to use this chart. You're looking for 0.92. 0.9 is right here. 2 is right here. And where they meet up is at 0.8212. All right, everybody okay with this chart? Everybody good? All right. So that's where I got this value, 0.8212. And don't forget that always represents, your chart value always represents less than. We want to know bigger than or greater than. So we subtract it from 1. That gives us 0.1788. So depends on what my math lab wants from you at that moment. They could want 1.1788 or 17.88%, or you could even see about 18%. So either one of those are legitimate answers. Oh, somebody said something. All right, and so one of your classmates just reminded me about the videos from the lectures from last week. Had a little bit of a hectic weekend, so I'll make sure I get that out to you guys today. I was going to get it out today, so sorry about that for those who may have been looking for it on a Friday. All right, is everybody good? Let me scroll up. Everybody done with purple? Okay. Let's see, can I get the bottom? Nah. Okay. So I'll give you a chance to write it, but Samuel Morse, inventor of the Morse code, claimed that the letter used most frequently in the English language was E, and that the proportion of E's was 0.12. We took a simple random sample with replacement from a modern day book. Our sample consisted of 876 letters, and we found 118 E's. So P hat is 0.1347. So there's a little more to it, but I'll give you guys a chance to write this before I scroll up. All right. And so before we go to the next statement, this P hat, and you see I wrote it right here. They calculated that by doing 118 over the 876. So it's 876 letters altogether, and they're 118 E's. So they did the 118 over 876. All right. So find the probability that if we were to take another random sample of 876 letters, the sample proportion would be greater than or equal to 0.1347. All right, scrolling up. So once again, we want to check our conditions. So math lab may or may not ask you. There probably should be one or two problems that will ask you, does this meet the central limit theorem conditions or criteria? So you should be able to answer yes or no by doing these three. Some of them will just get into the problem, assuming that that it does meet them. So, but I'm pretty sure there's at least one problem that's going to ask you about these conditions. So you do have to check them. Now, if you was doing this on your own and you were checking stuff like that, then you will have to check these conditions. If they don't meet the conditions, then you wouldn't be able to lean on normal distributions. You have to go a different route altogether and stuff like that. So all of these should meet it. And then if it doesn't, then you wouldn't go any further. So that's the type of problem that you'll have. So it's a random sample. So it's a random sample. You see it says that in the problem. Then we want to check to see if we get 10 successes and at least 10 failures. So we take our sample, which is 876, multiply it times the population proportion that they gave, which was 0.12. And that gives us 105.12. And then 1 minus P, which is 0.88, multiply that times 876. And that's 770.88. So we have at least 10 success, the possibility of at least 10 successes and 10 failures. All right. And then the last one is a population at least 10 times the sample size. So 10 times 876 is 8760. So the book contains far more letters than that. So they didn't give you a number, but it's easy to assume that your book is going to contain way more than 8,000 letters or 9,000 letters. Go there and round it up. Yeah, one of the joys of working from home, you hear doorbells. Hold on, class. Give me 1 second. I'm sorry. All right, my apologies once again. So now that we've checked our conditions and we meet the conditions for all three, we can go ahead and calculate. We can move forward in the problem, calculate our standard error. So that's square root of p times 1 minus p over n. I curved that up. All right, and we get that 0.010979. So you always want to round this out to at least 4 or 5. I like to go 5 or 6 because the more accurate, the more decimal places you go out, the more accurate your answer will be. So I always go 5 or 6. Most definitely don't do 2 or 3. That's too short of a decimal place. Because when it comes to mathematics, whenever you round a value, the shorter you round it, the further and further away you get away from the actual answer, with the more operations that you apply to it. So, you add something to it, multiply, divide, whatever you do to it, the more operations you apply to it, the further and further you get away from the actual answer. So you always want to go at least 5 or 6 here to be as accurate as possible. Most definitely do not go as short as 2 or 3 decimals. All right. So once you calculated your standard error, you can go ahead and calculate your z-score. So they gave us a p hat at 118 over 876. They gave us p as 0.12. And then we calculated our standard error as 0.010979. So if they're in calculated, we get 1.34. All right, so go to the chart, get our chart value. End up having 0.9099. All right, let's see what we're looking for. Go back up, greater than, right? In the blue, is that different ways to do the problem? When you say in the blue, are you talking about this right here?
Yes.
So no, well, no, this is just one way. I was just putting the values in and just doing it step by step. If you threw it in the calculator right here, it would take you right here. Yes, I was just doing the steps inside of the radical.
Oh, okay. Yeah, because that's what when I did the problem that you had circled, I was like, I came up with that answer on the bottom. So I'm just like, oh, okay,
Yeah,
it's different ways to do it, or
yeah. I was just doing order of operations, like you had to do this first, like if you were actually doing steps. Yeah,
oh, okay.
yeah, but it's most definitely fine to just do this to go right here.
Okay, thank you.
Yeah, no problem. All right, everybody good before we go to the next step? Evaluating for the answer. Okay. All right. So don't forget, chart value always gives you less than. And so if we want to know greater than, because that's what they ask us, going back to the problem, greater than, we got to subtract that from 1. And that'll give us 0.0901, which is either, it could be 9.01% or about 9%. All right, questions, any questions? All right. That's it for 7-3. Let's see how long is 4-7-4. Let's see. And then 8-1 is this. That's 8-1, 8-2. Trying to see how my sections lining up, see how much time we got. Okay. I want to start this today. You know what? I want to pause right here and give you guys a chance to digest this. I think it'd be good to end the week on 7-4 and then come back next week to start. Give you guys an opportunity to ask questions, see if you have any questions generate over the weekend and stuff like that. So yeah, let's do it like that. Just trying to map this thing out in my head and map it out according to the rest of the semester. So
Can you
yeah,
go back up to the purple for me?
absolutely
Right
not.
there.
Just messing. Yeah. All right. So yeah, we're gonna pause right here. I think this would be a good place to stop. Like I said, give you guys a chance to digest, and we can close out the week just doing 7, and next week get into chapter 8, and give you some breathing room. Okay. So, but before we do that, before we close out the day, did anybody have any questions on anything? Anybody try anything, even out of any other previous chapters? Everything is open right now. Anybody try anything, get stuck on anything? I know a few people still need a little more time to get caught up on some things. So
I was just about to ask, did you get my definitions this time?
when did you send them?
A couple days ago, I think.
Okay,
2 or 3 days ago, not yesterday, probably the day
okay.
before.
On this thing, I see pre. So is that what I'm going to look for in the email?
Lucretia.
Okay. All right.
And I did email it. Last time I sent it like some other kind of way, but I emailed it.
Okay. Yeah. Now, is it coming from your TCC email address?
I think so. But if it comes from my Gmail, it's still Lucretia Ankrum.
Yeah, I don't see it. I saw where you sent your. I have where you sent your chapter 1, chapter 2 definitions. I don't see. Are you talking chapter 1, chapter 2?
No.
No, you're talking about chapter 7, right?
Mm-hmm, mm-hmm.
Yeah, I don't see it. I'll do a. Let me see.
I'll send it again.
Yeah, try sending it again because I don't see anything coming from you for chapter 7 definitions.
Okay. I'll send it again then.
Okay.
Thank you.
Yeah, no problem. All right. Anything else? Anybody else before we close today? Pretty good. Okay, so next class we'll do 7-4, which will close out chapter 7 for us. And once again, I'll open up the floor, see if you guys have any questions on anything, and then we'll look to jump into chapter 8 next week. All right. So if you guys are good, I'm good. Have a great day, and I will see you next class. Thank you. Thank you. Take care. You have a good one as well. Oh, have a good one. Take care.